Hello, welcome to this part of our tutorial. Today what we're going to do is we're going to look at another software product of the Petroleum Expert, and the software we're looking at today is GAP. GAP is the acronym for General Allocation Package. G for General, A for Allocation, and P for Package. It is used in connection with MBAL and Prosper to model the full field. It's a very robust and powerful tool. You'll really like it. So today I'm just going to take you through the general overview, the windows, and the things you need to do. And then in the next tutorial, we'll simulate a very simple field and then see how these things actually work. So if you look at my screen now, what you're seeing is the GAP window. If you open a fresh GAP window, this is what you have. I have not created any file yet. So you see everything is disabled except the basic icons, the open, the new, the open, the save, and the new window icon. So if you've used any software before, you will know that this is the menu bar and this is the toolbar and this is your window. Okay, and this is status bar. Yeah, this is the status bar. So if you mouse over any icon here, you discover the label of the icon shows here. For example, just keep your eye here. So you see what you have there is new file, what you have here is open file, and that. So it's just there to help you. Okay, so let me create a new document. So I create a new, and this is the new window. You see the icons are now enabled, and then we have new menu items in our menu bar. Okay, so this is just let me start from left to right. So this is file. As you know, you create a new document, you open, you save, and all other things. You edit the new file, use good relations. Let's leave that. And the options is the next thing, very important. This is where you define the type of model you actually want to run. If it's a production model, a production field, if it's an water injection field, or if it's a gas injection field, if it's a gas lift system and all that, you use this. And you also edit your injection field, the properties. You can edit your tax regimes. This one is actually used in calculating doing economic analysis. So if you input your tax regimes and all that, your emotion models, you can edit them here. You can edit the system settings. Let's look at that. So this is the default water injection fluid, but you can edit that in the edit field. Of course, you can edit the properties of this default water injection and then the default gas lift injection fluid, emotions, and all of that. So do well to look at those, to look at this. Try to edit each and every one of them and see. But if you're not sure of what you're doing, please leave the values the way they are. Okay, so that's for the options. You can edit your system summary and you can view system statistics. You can disable automatic masking. Masking is very particularly useful if you want to simulate a period of time where your well was actually shut down or shut in. Okay, so you use masking to do that and all that. And then you can disable system validation. You can disable label validation. You can disable Prosper and GAP all time validation. Okay, so the next thing which you can do is to view. Like now, you look at my window, you see grid lines. You can actually disable that. And you say draw grid. No, I don't need a grid. And you see the way my window is. But I particularly like the grid, so I'll turn that on again. So you can do a lot of things here, the labels and all that. Just customize it the way you want it. So it's your stuff. Okay, now the next thing is the edits. This is you use this to select, to undo, to play a list of things you've done and all that. Just take your time and go through this. This one is good. The constraints. This is where when you start using GAP, you discover some of your production system, like your separator, might have some constraints, like the maximum number of fluids it can handle at any point in time. So this comes in very handy when you want to set those constraints. So you use this to set constraints on particular objects. What you do in a real field, you can simulate that here. So this is a very powerful tool. You can edit the constraint table, set abandon, and all that. You use this to set well IPRs and VLP. Of course, you can actually generate this and import to GAP. You can generate the well IPR in Prosper, and you can also generate the well VLP in Prosper, and you can import it here. But if you don't want to generate there and import here, you could come here and Prosper, and GAP, you'll have to call Prosper to generate it for GAP. So it's the softwares are linked together. GAP and Prosper and Embal were meant to work together with GAP. So these three packages are meant to work together. So GAP can actually colonize them at any time and get data from them. So that is the way it works. So you use that. They are disabled because there are no wells in the system, so you cannot generate anything for the system. That's why they are disabled. So you use this to validate your models. Use this to solve your network. Solving a network is just like solving a normal equation. When you have all your items together, and then you want to know what they can produce, you want to know the rate at which they're producing currently and all that, you use this to solve the network, and to perform all the basic calculations and just output the values in drop downs or in the results summary section. So you use this to run predictions. You can actually run prediction after you have your system to see how long the system will produce. You set particular constraint and at particular conditions. Okay, what if this is this? What if the pressure reduces? What if I choke this well this much? What if I place this particular constraint on the system? How long will this system run, and at what will it produce, and all that? So you can use this as a very powerful prediction tool. So you can use this to view your results, detailed summary, and all that. And you use this to generate reports. You can generate reports either to printer, to file, to clipboard, to all that now, depending on what you actually want to do. And this tells you the windows that are actually active. So I am actually working on the production system. Anyway, we'll look at that. This one is very, very important, the units. I'm using all field units, but you can choose any of this, and do well to always edit and check those values. So my solution is reported in feet per second, as feet per second squared. Absorption diffusion constant is recorded in the inverse of a day, and just go through all this. And the validation inputs, this one too is very important. It's saying that your connect gas ratio, water gas ratio, it should be between 0 and 1000. If you don't want that, you can actually change. This is used in checking the range of values which you enter. So Prosper will check and say that this value is not actually valid. It should be between this range and this range. So this is very powerful. It's used for validation. Okay. So that's that. Use this to get help and some other stuff about Prosper. Now, what you see here is the same thing you're seeing here. Just that this one's you're using icons for this, while this you're just using text. So everything in file, the new open save is what you have here. New open save. The new window is what you have here. Okay, new window, right? And this is where you edit your equipment control. This is where you run your network solver. Remember the network solver here, run network solver. Okay, this is where you write your scripts. If you've used Excel, the advanced form of Excel, advanced functions in Excel like the VBA, Visual Basic for Applications, you discover you can actually write VB scripts scripts that can run in Excel. So you can do something similar to that here in Gap. You can actually run some scripts, and of course this is VB sub and end sub. So this is VB scripts. So you can write the scripts and run it against your equipment, your tools, what you have here. But that's not what I'm going to cover. I'm just showing you what you can do. Okay, so then you can also run prediction. What you have here, prediction, run prediction. So that's what you have here. So if you prefer clicking on icons, then click on this and all that. So this will be very handy tools. Now let's look at this section, because this section is actually very important. Now this is where you add your separator. You add a separator or an injection manifold. So that's a symbol for your injection manifold actually. And also, so if you click on this, and you see, if you click on any of these icons, they get depressed. So they are now in the depressed state. So to place the icon on your field, all you have to do is just click anywhere on the field. You see how my mouse looks like. So if I click here, now that's what I have. So that symbol there is my separator. It's actually disabled because it's not connected to anything. Anyway, I'll show you that in just a few seconds from now. So now the label is separator 1. I'll just allow it at that, sep 1. Okay, now I am modeling a production. This is production model, so that's why what I can add is a separator. For me to be able to add the injection manifold, then I have to change this from production model to water injection model. I'm coming to that. Okay, this is used to add joints. Joints are just points where two or more pipes meet, of course. So that's what you do. Also when you're having two or more pipes and then they're meeting at a point, you use the joints to hold that. You can use it to also mimic your wellhead and some other stuff like that. This is a pipe or a link. You use it to link components together, to link items. Just use it to link items in your field. This is a well. So let me just add this. I will add a joint. So this is my joint, and it's called J1. I'll allow it to remain that way. This is, I will not use this for now. I'll use it when I'm linking the items which I'm dropping. So now this is my well. I use this to add a well. So I'll just click here, and that's my well, W1. Okay, this is your tank. Remember, MBAL uses tank model. So that's your tank, and it represents your reservoir. So I'll just click that and add it somewhere here. So it's called T1, tank 1. Now this is a flare. I won't add this for now. If you're producing excess gas and you want to flare it on the field, you can use this to mimic that behavior. So this is your pump. You know what a pump is for. This is a compressor. You know the function of a compressor. That is a source and a sink. This is an inline element. This is an inflow, and you use this to group fields together, to group sections of the fields together. This is a flow sheet. Use it to add flow sheets. So these are your controls, the controls you'll be using mostly. Now these are just zoom tools. You zoom in, zoom out, and then you unzoom. These are masking tools. Use this to mask, and then to disable. This is movement tools. To edit, use this to delete, use this to move. For instance, I can move this tank from here to somewhere else, so I can move it back. That's just what you use the move tool. Let's say at a certain point, maybe I placed this mistakenly, this tank. I could come here and I'll delete the tank. Click on the delete icon and then click what you want to delete. Okay, so you use this to select, to highlight particular items you want to deal with. Maybe I want to deal with I want to edit the values of this, or okay, let's say for instance I want to generate IPR and VLP for my well. So all I have to do is just click this and select the well, and then I can come here and generate whatever I want to generate, because you see they are now enabled because I've selected that. So anyway, and then you use this to unselect all items you've selected. So this is if you need to find equipment, you use this. And also you can do, okay, this is, if any of this is enabled, it shows you the model you're actually working with. So since I'm working on a production model, the production, this one is enabled. If I switch to water injection, this will be enabled and all that. So this is your index and the undo button. Okay, let me place my tank again. Okay, T1. Now let me place another joint, and let's see how we can join these things together. Joint 2. Okay, let me move joint 2 upward and move joint 1 downward. Sorry, you may not really see what I'm doing because the icons are all gray, but that's why I need to add to link them together. And watch what happens when I link. I'm linking my tank to the well, okay, and then my well to joint 1, joint 1 to joint 2, and then joint 2 to my separator. Of course, you can now see what's happening now. So you see, so that's the linking. Now this is just a link, alright. This too is a link, but here it has turned into a pipe. This is a pipe now. So now, because I'm joining a joint to a joint, it's a pipe. But if it's a joint to a component, it's just a normal link. So this is a well to a joint, and this joint actually will represent your well head for this well, right? So this is from your well head to maybe your jug manifold, or your what's it called, your manifold, whatever, and then from there to your separator. But sometimes, most times, when you're actually doing a drill field, it's more complex than this. In that scenario, you may be having more than one well. So let's add another well again, called well 2, and let's link this. So I'll have, first of all, let me add the well head for well 2 here. It's called joint 3. So I'll come here and I'll join my tank to well 2, and then well 2 to its well head, and then the well head to those joints here. Okay, let's rearrange the system to make it look better. So the well head should come here. This well head. The well head should come here. Okay. So let's do this. Okay. Okay. Anyway, so that's what you have. You notice this one's, the wells, they have red circles around them, and this joins to this link as a red circle, my tank as a red circle, and the pipes here, they are actually heights. It shows the data in them are not valid. Okay, so that's what it shows. And then to check what I'm saying, you can click on any of these components. Okay, let me at this point mention that you can change any of these labels. Let's say I don't want this well head to be joint 1. I have to do is click on the joint and then come to the label here. So I'll change that to let's say well head 1. Okay, so I can now click on OK, and it is changed. So I can also do the same for this and call it well head 2. Okay, so you can do that at any point in time. Now let's go back again and look at this. You see all the components we have in our system, they are here, and the ones that have valid data are marked this way. it has a tick, a green tick beside, but the ones which data in them are not valid are marked X, red. Okay, now let's start from our tank. So I'm clicking on the tank. So the tank is now what I'm viewing. You look at this, the label is T1. You can also change the label, like I said, the name, or you can skip this, and comments you can skip that. Now it says that the model is mature balance, the type is oil, but there's no pivot model, and the tank is supposed to link to an embal file, but no embal file has been supplied. So it says the embal file is missing. Of course, you need to model your tank in embal like we did. I told you, you link these three things together. You link your prosper and your embal to gap. So this is where you ought to do the linking, but the file is missing. Now there are two ways to do this. If you have an already existing file, all you have to do is to click on this browse icon and locate that file and import it here, and this will change to green. If you do not have a already existing embal file, all you have to do is to click on this and you run embal. So this will open the embal window for you, and then you can do whatever you want to do. You model your reservoir, and then you can click on the gap icon. Anyway, let's just do that. So I do not have an embal file. Let's assume I don't have an embal file, so I'll click on run embal, and you see it has just brought up the embal window. You see, now this is gap. So once I'm done with whatever model I'm done with modeling my reservoir, all I have to do is click on this gap, and then it will import everything to gap. But fortunately for me, I have an embal file because I don't want to prolong this tutorial. So the embal file which I created in my previous tutorial is what I'm going to link here. So I'm just going to click on this. So I don't want to import anything, so I just click here, and so let me import my file. So I click on browse. Okay, so I have to look at where my file is. It's actually in my desktop. Where are you? Desktop gap. So this is my embal file reservoir. So I click on that, and then I open. Now you see it's now valid, and this is the path to the embal file. Now you noticed before I did that, these points they were actually blank. Now they are now filled. It shows that I started production. I have one tank, and the tank ID is reservoir A, and the production, I started production on the 1st of January 2006, and I ended production on the 1st of October 2008. Okay, and then my OIP is 425.704. there is no gas. Okay, so now the embal here, okay, I don't think it should be okay now. No constraints on the system. Okay, so that's just for the summary section. So for the input section, this is where you can set your constraints. So there are no constraints on the system, and I don't want to set any constraints because I want to produce full. Now injection fluid, this is, like I said, under the edit section you can edit this, but we have gas O1. I'm not really gonna use it, but these are the properties of that fluid. You can always edit and whatever you want to do. Wells, there are two wells connected to this reservoir, well 1 and well 2. You can always remove any well you don't want, disconnect them and all that, but it's just showing you what you did here. Sorry, I don't want to do that. Let's click on this here. Well 1 and well 2 are connected to my tank, so that's what it's showing you. Okay, and then we have schedule. You can create some schedules like what you do in real life, when you want shut in and all that. Okay, and then the result section shows you after you've solved your model, you should have some things here. Okay, you should have some results here. Okay, now if you look at my tank now has a green tick, that means I have valid data for that. Okay, so we'll just leave that. The circle is gone. Now let's look at well 1. I click on well 1 and the same thing. Let's start from the summary section. It shows the IPR is invalid, VLP is invalid. Wow. And the other ones are valid: controls, downtime, coning, schedule, constraint, and all that. It shows there's a missing file here, and the missing file is Prosper file. The well type is all producer and lift. You can actually change this, but there'll be no need to change them because once you import this, okay, if you import this, it should auto detect model, VLP, IPR intersection, and all that. Read model is use volumes and all. So like we did for our tank, if you have an already existing Prosper file, you click on this. If not, you click on run Prosper and it should open the Prosper window. Let's try that. Click on Prosper. It says starting Prosper. So, and this is a Prosper window. So after you're done with your model and everything, just click on gap and it will take everything back to gap. But I have a Prosper file, so all I have to do is click on this and look in my Prosper file and associate it, and it's now showing valid. Okay, so now let's look at the input section. Input section shows the DP control. If you actually want to control the pressure and all that, if you want to automatically choke your well, you want the well to be controlled by the choke manifold. You know, we connected a well to a central manifold, so you want to control it from there, the amount of fluid you want to produce and all that. You want to control your well like it's done in a normal field. You have to set this on, but for now let's leave it at none so you can make it a fixed value calculated or what. Okay, that's for controls. The IPR section, it's showing red. The VLP section is also showing red. It shows that some data that have not been supplied. The RPL layer, you see everything here is blank. So the model we've just imported, the IPR has not been read yet. So that is what we are going to use the generate IPR and VLP button, the one I showed you while I was introducing the menu bar items. So we'll use that to generate this automatically. We don't need to input that. Also, the more let me change this. It says relative permeability, prediction, fractional flow model. I don't want, I have this thing already. I have the fractional flow model from my tank, so I'll want to read that from tank model, so I'm changing that to that. Okay, so we can just look at this icons, these values, and check what needs to be supplied. But I don't touch anything here. When we generate well IPR and VLP, you'll have values here. Now grid view, we've not actually solved anything, so we do not have values here. Just allow them to be the way they are. Let's look at our VLP. VLP says invalid VLP file. If you have generated your VLP in Prosper, you can at this point link it, but if you've not, leave it. We are going to generate everything here. You can also use this button to generate the VLP, but I'm not going to generate it yet. I'm just showing you what you can do. So this is coning. Let's just leave this, just click on and see what's happening. Okay, this is the result tab. After you've solved, you should have values here. You know, there are two sections: the network solver and the prediction. So if you solve, you have values here. If you're predicting, then your result will also show here. It's the same thing for the tank. The tank has two sections: the solver and the prediction too. Okay, so I'll just go okay, but the red circle is still there. Why? Because there's still some errors that needs to be addressed. So the same thing here, the summary section, there's no Prosper file. Wow. So let's just leave that. If you have another Prosper file, you can link it to this. Of course, you know, no two wells are the same. So the properties of this well, if it's the same, you can associate the same Prosper file. If it's not the same, you associate another Prosper file. Let's first of all let me associate the same well model for want of time. Okay, let's leave everything the way they are now. So the next thing I would want to do is to generate my well IPR and VLP. So I'm coming to this, generate. First of all, generate the well IPRs before you go to the VLP. So click on generate well IPR. And it says I should select. I want to generate for all the wells I have, so I just click on all, and I have 2 wells, of course, that have been selected. So I click on generate. So it will take Prosper some time to calculate, and it's done generating. So I click on OK. I can validate to see if actually something has been generated. So I click on this well. Let's go to IPR. IPR is not green. That means it has valid data. You can click on that. And let's see, IPR layer. I have values here now. Wow, see. Very wonderful. So we have value, the PI, and so everything is now okay. The more, everything is now green. But the VLP is still red. So let's go and do that for VLP. Okay, so I now go to generate and VLP. So I want to select. I'm selecting both. I'm generating from my gap model. So first of all, before I generate well VLP, you have to check the data. VLP uses some parameters to. So let's look at the parameters. We have liquid rate, manifold pressure, GOR, and water current. It's been auto-filled for me, but if you do not have values here, then you have to use it, fill it yourself, either manually or use the populate button. Okay, there are ranges of values which are recommended for each of these parameters. Your water current recommended range is from 0 to 90. Sometimes it can get to 99, as high as 99. It depends on what you're actually modeling. Now your GOR, I have from 280 to 10,000, but your GOR you can use from 250 to 10,000, or depending on what you're actually doing. Since I'm modeling oil well, I think 280 to 10,000 is pretty good for me. It covers all the range of gas oil ratio which I might actually come in contact with for this well. My manifold pressure use the minimum value should be about 100, of course 100 to about 5,000. That's also the recommended range for this one, 100 to 5,000 for oil wells. My liquid rates, the recommended range is from 100 to 30,000. Now the spacing for liquid rate should always be geometric spacing, so that it will cover a wide range of rates. Your manifold pressure should have linear spacing. Your GOR should have geometric spacing. What I call is actually linear spacing anyway. So since I have the values already, I'll just go OK and then click on generate. Now generating will take some time. This is the activity or the task that takes the most time in your model in CAP. So you really need, if you have a very huge model, like a very complex model, generating the well VLP might take hours, days, sometimes weeks. So you really you would want to have light, steady power supply to do this, and most times this is done overnight. You just click and then allow it to run all night to generate. So let's just hope this will not take too much time, but I'll have to pause this while it's generating and then resume after it's done generating. So I click on generate and watch what is happening. So like I said, it will take some time, so I'll have to pause this and then we'll be back once I'm done generating. Okay, welcome back. So we're done generating and it took at least 5 minutes for this to complete. So we now have our VLP generated, and I click OK and go OK. Wow, the red cycle is gone from this, but we still have this here. Let's check what the problem is. Okay, it's actually from our IPR. What's wrong with the IPR? Oh, the fractional flow. So let's change this to tank model and click on OK, and our model is now valid. Okay, so that's that. We are now done with the tank and the wells. And next thing we want to look at is the pipe. Of course, this is your well head and this is your central choke manifold. So this well head, this pipe actually has a length and some other properties. So all you have to do is to click on the pipe and supply that. So I'll leave the environmental parameters where they are. The overall heat transfer coefficient is 8 and oil heat capacity, gas, and all. Go to description. This is the only thing I'm going to touch. We have to define the type of pipe. Show coated flexible fittings. I'm using line pipe. I have to specify the length of this pipe. The length is in feet. How long is this pipe? Let's say it's 1,000 feet long. And now the TVD. Now the TVD starts from. Now let's look at this. So we are looking at upstream and downstream. So the definition is from upstream to downstream. So the top here should give you the upstream, and they should define the downstream of our pipe. But you can always swap notes. Let's say you want to define from downstream to upstream. So if you click on this, it changes. Now you're now supplying from upstream to downstream, but that's not what I want to do. I want it to be from upstream to downstream. Okay, so upstream to downstream. See the arrow, the way it's pointing. Okay, so downstream is, upstream is 0, downstream is about let's say 400. What parameter do I have here? I can actually have value here in feet. In kilometers. Let me supply the value in kilometers. So I'm going to change my units to kilometer, change this one to kilometer, change this to, okay, let's allow this to remain in inches. Okay, so what I have here is 0.2 kilometers, and I have, okay, this is in feet, and what I have is 20 feet. The inside diameter is 4, so I'll leave that and click on OK. Now it's changed from white to blue. So I'll do the same here. Description, line pipe. This is in kilometer, F.3. This is from 0 to 20. The next one is 4. Okay, so everything looks fine, but one problem I have is in this model the separator is actually in this field, so the separator is very close by. What if the separator is somewhere very far, like maybe you're transporting this maybe through underground pipes to very distant location? In that situation you need a pipe here, right? So you know how to add a pipe. But for this scenario, I think this suffices. Now let's mouse over these icons, and what do we have? Nothing is coming up. That's because we've not solved a network. So the next thing we have to do after supplying valid data for everything is to solve the network. So I'm going to come here and solve. I run my network solver. I need to specify a pressure for my separator. The separator pressure is at 250. So I go next and I am going to calculate. Now, the things you need to observe here, we have modes of calculation: optimization, optimize with all constraints, and optimize with potential constraints only. There are no constraints on my system, so I don't have to use this. If there are constraints, that's when you use any of this. Okay, let's just imagine nothing's wrong with the system. We want to run everything to full production. So how much will we be able to gain? So I click on calculate and allow MBAL to calculate for me. So it's done. Just took less than a second to do that from the log. So the script, nothing, messages, I think we're good to go. So I'll go to main and let's mouse over and see what happens. Of course, we have data now. So you see that pop-up box there shows that the oil rate from this tank is about 15,330 STB per day. The water rate is at 4,374. The liquid rate is about 19,000, and we have water cut of 22.2%, color gas ratio, all that. You can also access this result by clicking on any of this, and then you go to result section, network solver. You see we now have values here. So from there you can check everything that I just read out for you. Okay, so the same thing here for the wells and for our tank. So we're producing 15,324. Okay, now the question is, what if a tank is not able to, our separator is not able to contain that quantity? So in that situation, we have to set a constraint on the system. Let's say our separator can only handle, that's our protection rate, our separator can only handle maximum liquid rate, right? Maximum liquid rate for a separator is 10,000. That's what it can handle. 10,000 STP per day. So what if that is the situation? In that case, we have a constraint, and you see this red arrow here, we have a constraint. And then for our system to honor that constraint, we have to make sure that the wells can be controlled from our choke manifold here, right? So all you have to do is to set your well to be DP controllable. You can do that one of two ways. One, right click on the well and then change it to controllable. So you see this well head choke can be changed by optimizer. So now you have a red circle, but this is not the red circle for error. You know, the other one was larger. This only shows that there's a that this is controllable by our choke. So I'll use the other method for this. So I'll come to this and go to input control. Now change the DP control to calculated. Okay, so that's what we have. If you check this, it's the same thing. The DP control was changed to calculated. Now we can now run our solver again to see. Since initially we're producing 15,000 and well 1 produced 7,006, well 2 7,006. I think since they have the same properties, I use the same IPR file, so they should contribute the same. Now let's solve this network again and see what happens. So let's use this one this time around. Solve nest, and then I want to optimize with all constraints this time around. So and then I'll click on calculate, and it's done calculating. So I go to main. Let's see now what's the production here. Liquid rate is still 19,000. Wow. So nothing was done. Oh, sorry, I made a mistake. It's supposed to be maximum, but what I'm having here is minimum. sorry, that was my mistake, sorry for that. It ought to be maximum liquid rates 10 1 2 3. Okay, so sorry, that was actually my mistake. So let's run our solver again. Next, optimize and calculate. But let me do something. It's good to come here and then refresh this, reset this, in case any of this was set in the previous run. So reset a couple of times, click on OK, and then you calculate. Okay, so it's done. And now we not only have a log, we also have some messages in the limiting section, and it says that the maximum liquid rate for the separator has been constrained to 10,000, meaning it could have produced more but for the constraints which we imposed on the system. So let's go to main, and now if you check this, you're producing an oil rate at 7,780 and water rate at 2,220, and our liquid rate is 10,000. So, and you check the warning there. The warning says maximum liquid rate for separator constraint limiting to 1,000. Okay, now what's the contribution per well? Well 1 is giving me 4,000, oil rate 4,066. Well 2 gives 3,713. Why the difference? Let's look at the water cut. Water cut is 22.2%, and water rate for this well is at 1,059. Water rate for this well is at 1,160. Water cut is 22.2. Okay, so that's what we have. That's how to model this. So I think that was long enough and simple enough. So that's how to do your field modeling. Remember, this is a very simple scenario. What you actually do in real life is much more complex. I don't think there's a field that has just 2 wells and 1 reservoir. Okay, so anyway, thank you very much for watching. If you have questions, please do well to ask, and don't forget to subscribe. It's very important, and to share the video. You got it freely, share freely. Contact me using the details you see on the screen now. Have a nice day. Bye for now.